All right, here's problem 11. The diagram below shows the graph f of x equals x squared times e to the negative x. There are points of inflection at A and C, and there is a maximum at B. Use the product rule to find the first derivative. All right, so they gave us some hints. I'm going to do it up here. U is going to be x squared, and V is going to be e to the negative x. So the derivative of U is 2x. The derivative of V is going to be e to the negative x times the derivative of negative x, which would be negative 1. Now I'm going to crisscross applesauce. So I get 2x times e to the negative x plus, so this way, negative 1, I'm going to start with that, negative 1 x squared e to the negative x. So I just multiplied these three things together. I like to start with the coefficient. Okay, so that would be f prime of x is this. I can also factorize this a little bit. I noticed that they have an x in common. So I could leave it like this, 2x e to the negative x minus x squared e to the negative x. Okay, I just simplified this part, made it just a minus. I could also factorize it. They both have an x, and they both have an e to the negative x. So if I take that out, and one of those x's out, I'm going to get 2 minus x, so it's left behind. Now find the exact value for the y coordinate of B. Oh, so this is going to be handy now that I factorize this, because at B, the slope is 0. And this is my quotient function. This is my gradient function. My gradient function helps me find the slope. So I know the slope is 0 at B, so I can find B by saying that 0 is equal to x times e to the negative x times 2 minus x, that is equal to the gradient function. So now I have the zero product property. I already have three things being multiplied together. I have x times e to the negative x times 2 minus x. So I'm going to set each of those equal to 0. So x equals 0, that one's done. E to the negative x equals 0, that one's impossible. You cannot take anything and raise it to an exponent to make it equal 0. So that one, there's not going to have a solution. And 2 minus x equals 0. Add x to both sides. You get x is 2. Find the exact value of the y coordinate at B. Okay, so I know that I'm going to have a maximum or minimum or some sort of stationary point at both x is 0 and x is 2. So here's 0, so that means B must be at 2. So the x value here has to be 2. So now I need to find the y value, and I should have given myself some more space here. And oh, I just noticed I did not do this problem on my my answer key that I made already. Interesting. Okay, so if I want to find the y coordinate, I now need to plug that back in to the original problem. So y is equal to x squared, so that'd be 2 squared times e to the negative 2. And if I simplify that, I get 4 over e squared. Okay, so that's the y coordinate. So that's the answer to part B, find the exact value of the y coordinate. Notice it says exact value. I'm saying this is a no calculator problem because they want exact values. They don't want me to round that off. So, so point B is at 2, 4 over e squared. But it just asks for this answer. That's the y coordinate. All right, the second derivative of f, and they give it to us. Use this result to find the exact value of the x coordinates of C. So notice they told us that C is a point of inflection. So the second derivative can be used to find points of inflection. So I'm going to set the second derivative equal to 0. Squared minus 4x plus 2 times e to the negative x equals 0. Again, use my zero product property. So I'm going to have x squared minus 4x plus 2 equals 0. And e to the negative x equals 0. That one's impossible. So I just need to solve this one. I want to find the exact value. This is not factorable. I can't find two numbers that multiply to give me 2 that are going to add to give me negative 4. So I'm going to have to use the quadratic formula, which is in the formula packet, in case you don't remember it. So it's x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. So I get, let me come over here with it, x equals negative b would be positive 4, plus or minus square root b squared minus 4 times a times c, all divided by 2a. If I simplify that, I get 4 plus or minus the square root of 16 minus 8 over 2, which gives me 4 plus or minus the square root of 8 over 2, which gives me 4 plus or minus 2 root 2 over 2, which can be factorized. 2 times 2 plus or minus square root of 2 over 2. And now I can reduce that. I can reduce out the 2's. So my final answer, find the exact value of the x-coordinate. X is equal to, it says 2 plus or minus the square root of 2. So notice there's two answers, and there's 2 points of inflections, A and C. So A is the smaller one, so the smaller one is going to be 2 minus the square root of 2. C is the bigger one, so it's going to be 2 plus the square root of 2. Okay, so A has an x-coordinate of 2 minus square root of 2. C has an x-coordinate of 2 plus the square root of 2 because it's bigger. It's farther to the right. So there is my answer for C. Okay, number 11.